So now I'm going to look at U substitution in the context of definite integral. Okay, so I want to know the definite integral of this expression, x squared plus 1 squared 2x from 0 to 1. So again, I could rewrite it. I could take this and FOIL it out. X squared plus 1 times x squared plus 1, probably give me what, x to the fourth plus 2x squared plus 1. And then multiply that by 2x, and I'd end up with a really long polynomial. And I could take the antiderivative of that and then evaluate that from 0 to 1. Okay, got that. Let's try U substitution. And again, I take a look at this and I see a relationship. If this is U, this is the derivative of that. So I'm going to write that down over here. U equals x squared plus 1, okay, and du equals 2x. So this is absolutely in the form of basically the integral of u squared du. Okay, so let's go ahead. Well, wait a second. Let's very quick, very slowly here. I got to be careful. When the integral was based on x, defined as x in terms of x, this was my set of limits, 0 to 1. Now I've taken a fancy shortcut, and I don't write this as x squared plus 1. I write it as u squared. So I can't use the same limits. I've got to translate everything in the context of u. Basically, I've replaced x with u, so I need to replace the limits. So what is u of 1? In other words, if I'm going to rewrite this whole function in terms of u, okay, I'm going to write the limits in terms of u. So u of 1 means if I plug 1 into here, what do I get? Well, u of 1 would be 1 squared plus 1. That would equal 2. Okay. And u of 0, that would equal 0 squared plus 1. That would equal 1. Okay. So if I want to rewrite this using the really slick little technique of U substitution, I can do that, but I've got to change the limits, and I'm going to change the limits instead of 0 to 1, it's going to be 1 to 2. Okay, so this is going to be 2, this is 1. So now I can go ahead and use my new technique, U substitution. So what's the antiderivative of U squared? Well, that's going to equal, so this equals U cubed over 3, okay, from 1 to 2. All right. So, and I'm going to pull the 1/3 out. I'm going to say that's the same as 1/3 times u cubed from 1 to 2. It's just, rather than having to do fractions multiple times, I'm going to do all the arithmetic to figure this out and then put 1/3 on at the end. Just, it's a simple technique to make things a little bit easier. This equals 1/3. Well, times what? So when I evaluate this at 2, okay, I'd get 2 cubed, right? Minus when I evaluate it at 1, I'd get 1 cubed. Okay, so this equals 1/3 times 8 minus 1 equals 1/3 times 7, okay, which equals 7/3. Okay, and I'm done. And if you want, and in class we'll do this. We'll actually take out our calculators and we'll plug this in, and we'll use second trace 7 and take the integral of it and evaluate from 0 to 1, and we'll find out it in fact is 7/3.